guys, how do you start this? What method do we use? Very good, very good. So we took this value, we plugged it in right here for that y value, giving us x plus 2 parentheses, negative 1/2 x plus 4 equal 1. This is where we stopped. We ran out of time. Okay? Now, start by distributing the 2. What do you notice? What's going to happen to your x's? Yeah, they're going to drop off. So you're going to get what? Is that true on 100? No, that is false. That is false. So, what's the deal? Yeah, good. So what kind of lines are these? When is there no solution? What kind of lines? Not vertical. Parallel. Remember, Nick, go back to look at your notes. We had 3 options. Either the lines can intersect with one solution, they can be parallel with no solution, or they can be coinciding on top of each other with infinite solutions. Okay. So again, when you get a contradiction, there is no solution to this problem. So is it worth even trying to go the other way and use elimination or plug it in? No. So you stop there. There is no solution. So again, just to verify this, no solution, let's just say parallel lines. That's what's going on here. And how can you verify this? How can you check that they're parallel?
If they have the same slope.
Yeah, they have the same slope. So let's see. This slope is negative 1/2 by inspection, right? You see, well, this slope, this is in standard form. Negative a over b is the slope. Negative a is negative 1. This is a right here, there's a 1. This is b right here, that's the 2. So negative 1/2. So both of them have the same slope, and they happen to have different y-intercepts, so that they are staggered away from one another. So we have this example right here of 2 lines that are parallel. Now, be careful though, because if they have the same slope, and they have the same y-intercept, then what case are we in? Yeah, they're identical lines. So if they have the same slope and the same y-intercept, we get this third scenario. So we can't just test the slope, but to verify that, or to make sure that our answer is correct, we should quickly look at the slope and see. Okay? Let's take a look at the second one here. Method. And then, yeah, good, very good. What you're noticing right away is we would want to use the elimination method. So multiply the first equation, the whole thing by 2. But you're going to notice that everything's going to cancel. Because you're going to get, when you multiply this, negative 6x plus 10y equal negative 12. So that's what we get in place of that. And now if you add that to the other equation, what happens? Well, that's an identity, isn't it? So which example is this one? Yeah, so I like the word used, the identical lines, because it's an identity. Again, this statement is an identity. Remember, this is a statement of no solution. Well, remember, when you have an identity, the lines are identical. Again, when you have an identity, the lines are identical. So what we have here is a graph where we have line, let's see, it's positive slopes. I don't know where the line is, so I'm going to save that one. If that were the first line, then this is the second line. And it's coinciding. It's right on top. It's overlapping. Okay? So that was the example from these 2. All right. Let's take a look at the next one here. This is a good SAT problem here. You see this a lot. Where you're given a problem where you have all variables here and you have to solve in terms of the other variables. So we get, suppose that 3x equals y plus 5 and 2y minus 2 equals 12k. Solve for x in terms of k. Solve for x in terms of k. Before we even begin the problem, because I know some of you know how to do this right away, but I want to go through it quickly. I want to say first, solve for x in terms of k. Translate that for me. What does that mean about your answer? What does that mean about your answer? Erickson. Close, not exactly. K does not equal x, but something along those lines.
It's like, how x equals like 2k.
Good. X equals something with a k in it. Not necessarily k, that's why I said close. So it might be 2k or 7k plus 5. So when you see this in terms of, it means that k is in the answer. Alright, so k will be in the answer. So it's going to be x equals something with all these k's. Now, what's the other variable in this problem that's not going to be the answer that still is there though? Y. But take a look, isn't y the linking variable? Isn't it in both equations? So if it's in both equations, maybe I can do something here. Any recommendations? Erickson?
Do you think isolate y on the other problem and plug it in?
Anywhere? Here?
Yeah.
Alright, that works for me. So move the 5 over. Agreed? That's what y is in terms of x, 3x minus 5. And then you're saying take that and plug it in right over here, right? I would do that. That works for me. So we have 2 parentheses. 3x minus 5 minus 2 equals 12k. And so Erickson, explain to the class why you chose to do that. What did that accomplish?
Now we only have x.
And? Very good. So what we've done here is we've used substitution method to actually eliminate the y variable. The y variable is no longer there because we've taken the definition of y, which is 3x minus 5, and we plug that in here for y. That's where it shows up right here. Okay? And now solve. What do we solve for, x or k? Everybody? X. How come? Yeah, because it says solve for x, right? We're not solving for k. So let's distribute. Combine like terms. Okay, let's move the 12 over. And then divide by 6. Again, remember, when you divide by 6 here, I'm not showing the step, but you're dividing a binomial by a monomial. So you need to divide each spot like this, and then divide this like this. If 6, or if the denominator were not 6, let's say the denominator were 5. Make believe for a quick second that this had been a 5 instead. Here, 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 and that's a 5. You would have this. Can you divide those? How come? Of? Good. 5 is not a factor of 12. Good words. Not a factor. Or 5 doesn't go into 12. So another way you could write this answer, had it been a 5, you could write it like this. But that's kind of, not needed. What else could you do? You could do this. Right? If I factored out the 12/5 out of both terms now, I can write it like that. But again, there's many ways you can write the answer. Why is it important? Who can explain this one? To know that, say this were our answer, make believe this was our answer. Why is it important to know that there are other forms that exist of it? Well done, Andrew. Well done. Again, this is the answer we got, but it might not look like that as a choice. This might be the choice at the bottom here, but you have to go through the steps of dividing by 5, factoring out the 12/5 to get there. So you need to be able to manipulate your answer. Right? Manipulate, change, alter. Okay? Any questions on this one? So what we've done here is we solve for a variable in terms of the other variable. So again, k was in our answer, and we had x equals this, x equals, and the y is gone. All right. Now, this is where the challenge comes into play. And this is a topic that is not in your textbook, just to give you a little heads up. This is something that I put additionally, because you're going to use this, you're going to use it in pre-calc, you're going to have to know how to do this in calculus. I'm also going to show you a shortcut to do this on a calculator. We're going to do it all by hand the first time. And then I'm going to show you how to do this on a calculator as well. Okay? How are you going to? Yeah, z is like where the x is coming out of the board. Yeah, so x, it depends on the mathematics or the teacher you have, but traditionally you can say x, y, and and then z comes out of the board. So it's the third dimension. Okay? Now, I can have 7 variables. I don't need just 3 because there's only 3 dimensions. I can have 7 variables, but then I would need 7 equations. Notice, there are 3 variables, right? X, Y, and Z, and there are 3 equations. It will always match up if you want to be able to solve. You want? You all right? Okay, we're going to wait for you. Go.
Take your time.
I don't know if this is the thing.
Oh, we're supposed to read.
Yeah?
Oh,
Water fountain's right there.
you get to ask this thing.
No, I feel like it's like her down. It's a little bit difficult.
Oh, there we go. We all have a copy now? Okay, let's begin. We have 3 equations here, okay? And in the past, we either use substitution or elimination. Tell me and give me a reason. Tell me which method you use and give me a reason why. Either are really acceptable, but one is better than the other, I'll be honest. There is one better answer. Pete, what do you think here?
Well, substitution would be, it wouldn't be very smart just because there's 3.
Yeah.
And when there were 2, it made a lot more sense because you had equals y, so y was this, but now.
Now it's fun, right?
There's a lot of things you can do, so, I mean, elimination would probably be easiest. I don't know if there's another way.
No, you're right, elimination. That's right. Elimination is different though because it's 3 equations, so I have to do it differently, but he's exactly right. Substitution is going to get really messy. If you solve for x in one of these equations, it's going to be in terms of y and z. Then you got to plug it in over here. Then you got to do it up here, plug it over here. It's going to get really messy. I would not recommend substitution. Now, this is where, remember the commands I gave you guys, like equation 1 times 2 plus equation 2 we wrote? This is where the commands are going to really come in. So here is the method. Or does anybody know the method to solve this? Has anyone ever seen this before? Jules, you saw once?
Yeah, I had to do it like last week.
Do you remember what to do?
I had to do like the first one and the second one and something had to cancel out, and then the second one and third one something had to cancel out. It was so tedious.
Yes, that's exactly right. It is tedious. We're going to do one example by hand, and then I'm going to show you how to do it on a calculator in about 3 seconds, and we'll be able to use it from now on. But I want to do one by hand so that we all know the technique. So, Jules is exactly right. Notice, we want to use only the first 2 equations first, or at least just 2 of them. It doesn't have to be the first 2. But use 2 of the equations first to eliminate one of the variables. Then use another 2 equations to eliminate the same variable, so that you get it down to a 2-by-2 system. And I'll explain what I mean. Take a look at the first 2 equations. See how these x's line up pretty nicely? If I double the second equation, if I double this and add it to the first one, these are going to cancel. And I'll be left with only y and z. Is that clear? So let's do that. Let's say equation 1 plus twice equation 2. That's our command. Again, take the first equation, let's rewrite it. So the first equation plus twice the second equation. Make sure you double everything. The most common mistake I see is people only double what they're trying to get rid of, and they forget everything else. So we're going to have negative 2x plus 4y minus 8z equals 10. Again, make sure you double everything in this entire equation here. Everything's got to get doubled in that equation. Any questions so far? Do we all see what's going to happen here for the first part? What's going to cancel, everybody? X. Cancel. Add them up. What do you get here? Equals? Now, this is a completely brand new equation. So we need to give it a new number. How many numbers have we used so far? So what is this going to be called? Now, another thing to know, and I don't always write this, but you can. The first equation, didn't we repeat it right here? Everybody see this? So this is really still equation 1, but didn't we change the second equation a little bit? So if you want to give these labels, you can call this 2a, and the a just means it's been altered. And if you alter it again, then it's 2b, or 2c, however many times you change or manipulate the equation. So this was taking the first equation and adding an altered version of the second equation, giving you a brand new equation down here, which we'll call our fourth equation, just because we have a third equation already. Okay? So Jules, I got rid of x in that part, didn't I?
Yeah.
So what should I do now, Jules?
Two of the equations to get rid of x again.
Yeah. Can I use the same equations?
No.
Good. So we can't use the same equations, right? So we're not going to use equations 1 and 2. Either use 1 and 3 or use 2 and 3 to get rid of x again. What's easier, everybody? What is it? 2 and 3? How come? How come? If I just add these, what happens to the x's? They cancel. So do I have to alter any of this? No. So your next command is just going to say equation 2 plus equation 3. Take the second and third equation and add them together. That's going to say negative x plus 2y minus 4z equals 5. And I write it out every time. X plus 4y minus 6z equals negative 1. Sum these together. X's drop off. We're gone with those. We've got 6y minus 10z equals 4. What equation is this? 5. The fifth equation. And now, as I said a little while ago, as Jules mentioned, look at equations 4 and 5. What variable is gone? Everybody. X. X is gone. So now we're back to a 2 by 2 system. So we can solve this one by elimination or substitution. I would stick with elimination, and I would solve this. Somebody give me a command for this one. Command, exactly written. 100?
2 times 3 is 4. Negative 2
Thank you. Okay,
plus 2
good. Again, take a look. Make it easy on yourself. If you multiply this by negative 2, you're going to get, if you multiply again this by negative 2, you'll get a negative 6y. And that'll cancel with the positive 6y. You can do stuff with the z's that works. You can multiply this one up here by 10, or 5 rather. Multiply this by 5, that'll give you negative 30. Multiply this by negative 3, that'll give you positive 30. But that's more work. Choose the easier method. Okay? Let's write this out. So negative 2 times this is going to be negative 6y plus 12z equals negative 6. And then we're going to get equation 5 and just add it down. So we have 6y minus 10z equals 4. Now, just for labeling and consistency, this first equation here, negative 6y plus 12z equals negative 6, what would I label that? What would I call that one? 4a. Because we've taken equation 4, which was right here, and we multiplied it by a factor of negative 2. So it's been altered. So this is really 4a. And we're adding equation 5 to equation 4a. I know the smart part isn't agreeing. Okay? When we add these together, the y's cancel. How many z's are left? 2z equals. So z equals. All right? So z equals negative 1. Am I done? What do I have to do still? What do I still have to do? Pete.
Well, you're getting all the letters you have to plug in.
Good. So Pete, I want to get something that's easy, don't I?
Yeah.
I got z, and here's only z and y. So should I plug it in here, or can I plug it in up here?
Where, well, I mean, either one is going to be easier than,
Very good. Good answer. Either one. Remember, if you try and take z and put it back in the original, it's not going to do much for you yet, because you don't have y. To use the original equations, there were 3 variables. Remember in the originals? You need 2 answers to use the original. So take this negative 1 for z and plug it either in equation 5 or equation 4. It doesn't really matter at this point, though. I'm going to put it in equation 5 just because it's lower on the board and I can see it. But take this, plug it in right here. You get 6y minus 10 times negative 1 equals 4. This is going to be really plus 10. Subtracting 10, we're going to get negative 6 equals 6y. Turns out y is also negative 1. Coincidence, just coincidence. Again, just coincidence that they happen to be the same. So if we get z and y now, then what will we do? Then, in where though? Yeah, into the original equations. So let's go back up to the top. If you plug it into, say again? It wouldn't help you because there's no x's there, right? Remember guys, we're looking for x. So let's go back to the beginning, and there's where x is, the very beginning. Which equation has x by itself? 3. Very good, man. 3. So it's the easiest one to use. Everybody see that? I would not use the first two. I mean, it doesn't matter. Same answer again. But use the third equation simply because x is by itself. Okay? Can we turn off the AC? What do you think? No, yes, no. I'm still a little bit hot, so I know. Is it not? I mean, come on. Yeah, I don't know. It's like really stuffy and stuff. Let's do compromise, man. 5 minutes off, okay? What? You want to do 5 minutes off in the back, huh?
Yes.
Let's just
Wait,
5 minutes off here.
5 minutes off and 5 minutes.
We got till 2:20, so we have another about 15 minutes. Turn it off for a few minutes and we'll put it right back on. Okay, let's let it give a second to warm up a little cold. So, in the third equation, let's plug in here. These are both negative 1s. So we have x plus 4 times negative 1 minus 6 times negative 1 equals negative 1. Okay, again, plug into the third equation. So we're going to have x minus 4 plus 6 equals negative 1. This is going to be x plus 2 equals negative 1. Subtracting 2, x equals negative 3. Okay? Again, I plugged into the third equation, both spots, negative 1 here, and then we get our answers from that. How do I write this answer in the final step? How do I write it in one answer? Yeah, in a triple pair, right? So what would that triple pair look like? Does it matter, right? Yeah, because they're the same. Negative 1, negative 1. Okay? They're both negatives. It's negative 3, comma, negative 1, comma, negative 1. X, Y, Z. Z goes last, traditionally. It really doesn't matter technically, but just so you guys know, you're going to write order pairs or order triples, X, Y, Z. Okay? X, Y, Z. How would I check my answer here? Nick?
Plug in.
Where?
Any problem?
Yeah, but to check really, you should really plug in the answer in all 3 and check 3 times. But I don't want to go through all that work, right? So let's go to our calculator now. I'm going to show you this method called the matrix. Okay? Did you have another question, someone before I
I was
go?
gonna say page graph, but that's still like.
Why can't you graph it?
Oh, there's a third value.
Yeah. You can graph it. You know, guys, in case you want to know, it's tough for me to show this. Actually, let me show you something really cool before we go to the calculator. If I can find it online, it'll be useful. All right, so this is going to sound really crazy, guys, but this is what's going on right here, just so you know. When you have x and y only, they're lines, aren't they? X by itself is just like a point. But when you have x and y in the equation, it's a line. Well, when you have x, y, and z, they're planes. Now, if there were no solution, it would look like this first one here. See how they're all parallel? They're not intersecting. What we got was right here, this second solution. Whoops. solution here in the top middle. The third solution is a little bit different. I'm not going to not touch on that just now. Down here, they're all intersecting. They happen to be intersecting at right angles. So these planes are normal to one another. It's called normal, meaning they're all right angles of planes. And then down here, this is again another contradictory solution. These ones here are where you're going to have ambiguous solutions. This is one solution. This is no solution. This is also one solution. But that's what's going on really, just so you know. That's why we can't graph and check the solution, because it would be tough to graph that, right? Okay? So what we can do, though, is use our calculator. And I'm going to show you how to do that. So, all right. Everybody, go to your home page, please. So press second, quit, or whatever you have to press to get there. Second, quit. Now, second and then quit. Say again, guys? Can I clear the ink? Come on. Oh. All right. Now, let's focus, guys. Let's focus. Everybody see the system there? Here's what I want you to do. I want you to think about, for this kind of a problem, how many equations you have and how many columns you have. So think about rows and columns. Rows and columns. So, what is a row? Nick? Yeah, a horizontal line. Very good. And what is a column? A vertical line. Very good. A vertical line. Why are you looking at me like crazy?
I know the word.
Oh, okay. I didn't know what you were saying. All right, so what we want to do is think of this like the following. That's the first column, second column, third, fourth, row 1, row 2, row 3. Everybody see what I'm doing so far? I know it looks a little messy, but you get the idea? Now, in your calculator, there's a function called a matrix. And the way you're going to draw this or write this is the following. You're just going to write your coefficients. That's all you're going to do. So let's write down our coefficients. 2, -1, 2, -7. That's my first row. Again, 2 is here. Then you have -1. Then you have 2. Then you have -7. Yeah, write this in your notes. Write the matrix in your notes when we're doing a calculator. Second row. Somebody tell me what the second row should read. Summer.
-1, 2, 4, -4 would be 5.
And somebody else for the third, please. For the third, Erickson.
1, 4, -6.
All right. So everybody see this so far? We're good? That's what a matrix looks like. Now, this matrix happens to have 4 columns and only 3 rows. So it's not a square matrix. What would a square matrix be?
If it was 2 rows and 2 columns.
Yeah, or 3 by 3 or n by n, we would say, right? Mathematically speaking. Any number by the same number would be a square matrix. All right, let's go back to our calculator now. We need to have that written down to do this. So we go to our calculator. We press second. Then we press, in my case, it's right here. Sorry, matrix is right here. Is yours above math? Look at the key math, right? I think you guys have to press second and then math. Do we all see matrix?
Yeah.
If you click on matrix, this is what it's going to look like. So tell me if you see that on your page.
Yes.
Okay? Go over to edit. So go press the right arrow key, and then press the right arrow key again.
I got a lot of stuff.
Again.
First is numbers in there.
Don't worry, guys. If there's numbers, we're going to write over. That means that somebody probably used it before. Is your brothers?
Yeah.
Yeah. So you used the matrix before. It's fine. So go over to edit and hit enter on matrix A. Now, somebody try it out and tell me what it is. Is it 3 by 4 or 4 by 3? Try it. Type in your calculator. make this a 3 and make that a 4 and see what it turns into. So first try doing this. Press 3 by 4.
When I press the matrix, it says these lines represent the answer. Okay, I don't know.
We're going to put the numbers in there. Now, here's what I want you to notice, because this is a common thing people don't realize. See the dashes at the end? That means you can go over further. So watch what I do. Look at the board, please. If I press the right arrow key again, and I go again, it'll go all the way over to the end of the matrix. So 3 by 4. So here's what I want you to write down, please, in your notes. Please write this down. This is a 3 by 4 matrix. So 3 indicates the number of rows, and 4 indicates the number of columns. Whenever you're doing a matrix, it's always rows by columns. Rows by columns. So if you had 20 rows and 35 columns, it's 20 by 35. Okay? So it's always rows by columns. RC. This is going to sound lame, but when I was a kid, there was a soda called RC Cola. Have you ever heard of RC Cola?
Yeah, my teacher used to say Roman Catholic.
Roman Catholic. Okay, that works too, actually, since we're in Catholic school. Roman Catholic. Remember, rows by columns. Yes? That's what we do now. We're going to put the numbers in. So let's put the numbers in together, please. What's another way there? John, what was another way? Yeah. If you need a mnemonic. So we have 2, enter. Now be careful, people. Take a look at the board. This is the negative symbol that I'm hovering over. If you use the minus sign, it will not work. So -1, enter. 2, enter. -7, enter. It brings you to the next line. Is anyone lost right now? If you are, please ask. -1, enter. 2, enter. -4, enter. 5, enter. 1, 4, -6, -1. So now we've entered the whole matrix, right? At this point, everybody follow me. Press. Press second, then press quit to go back to the home page. Trust me. Press second and press quit. You have to do this. If you use the next command within the matrix, it will try and embed a function into your matrix and you get an error. So you need to clear out, go to the home screen. Now, go back to your matrix. I know it sounds annoying, but go back to your matrix now. Go over to math. So you have all these options. Go down until you see R, R, E, F. And I'll explain what that means. Not ref, but R, R, E, F. Ref. Okay, R, R, E, F. Now, hit enter on that, please. I'll explain what this means. Now go back into your matrix once again. And just hit enter on matrix A now. So hit matrix, then hit enter. And close your parentheses. And then press enter. What do you notice, people? What was our answer for this problem? Wasn't it -3, -1, -1? Go back to your matrix. It means you, guys, if you didn't get these numbers, you made a mistake in your matrix, so you need to check your numbers with the actual equation, and you'll find it. So, here's what this really means. Let me actually write this in the smartboard and make it easier.
There's nothing wrong.
There's got to be.
You just said it's wrong.
I'm not messing with you. There's got to be. Keep looking. Maybe your equation we wrote wrong on your paper there. Maybe do you have this written down perfectly? Look at your matrix on your paper. Make sure that's written right. -4.
Yeah. No, both was -4. I'm just going down.
Uh,
2, -6. Yeah,
REF, hit enter, then go back into your matrix, press second matrix,
Wait, you just went back into my.
because you didn't clear out the home screen, remember? Michael. Now, guys, focus, focus. We're running out of time. Listen carefully. RREF means, you don't have to write this down, but it means row reduced echelon form. And the reason it makes sense is this. Notice, and I'll explain what echelons are. That's what your matrix looked like after you did REF, correct? Now, notice there are ones only in the diagonal. Only in the diagonal. This is the echelon. Each of these diagonals has a 1 and everything else is a 0. If I were to take the first row and write it as an equation, here's what it would say. 1x plus 0y plus 0z equals -3. That's what this first row means. Well, 0x and 0y, do they mean anything? So this just really says what? X equals -3, which is what we got before. Here, this, put an x here, whoops, put a little x here, put a y here, put a z here. This line means that y equals -1, and this line means that z equals -1. So what, and you're going to learn, when you take linear algebra, you're going to learn how to do this by hand. We call it row operations. You say R1 plus R2 replacing R3, and it takes some time. And you have problems that will take you like 3 or 4 pages, one problem. Okay, but you can practice it on your calculator. I see your hand. Just so you know, guys, tonight what I want you to work on is section 3.5. Section 3.5.